in this video, I'm going to talk about instancing in Bifrost. And this is going to be a pretty high level operation, so it should be good for everyone. That said, you're going to get more out of it if you're a bit familiar with arrays and properties. So this node here, create instances, is what I'm going to start with. So we need points to instance onto. And for that, we can use all kinds of point-based geometry. So we could use the scatter points compound. We could use points from particles. We could use a plane like this, any geometry, polygon geometry, or we could use strands. And then in here, we want to provide what we want to scatter onto those points. So I've got my plane already here. And if I don't provide an instance geometry and I plug that into the output, I'm just going to get spheres. But I want to use these individual three shapes here, which are these. And so let's just start with the cube. There we go, we've got the cube. And I can keep adding as many other geometries as I want. And there we go. Now there's a bit of a weird offset, and that's because these objects have transform values. So I'm going to zero them out, and this looks a bit more predictable. I'm just going to hide them. I don't want to look at them. But the point is, if you scale them, if you move them, that will be reflected. So, and if you click on this plus, we can see the order these were added. And at the end of the day, this is just an array of objects now. And because of that, we can refer to each element with an index. This would be 0, 1, 2. So let's look at the settings. We're getting this pattern here because this is set to sequential. And basically, well, let's look at the points here, the point IDs for my point positions of the plane. So we can see that this is the first point here and just keeps going left to right and bottom to top here. So what's happening is it's just going to repeat these first three shapes that we're plugging into here over and over until there's no more points left. And that's what results in this pattern. And we can change this selection mode, for instance, to none. If we do that, we only get the first shape. I've never really used this, but it's there. And then it's also random, which does exactly what you would expect, give you a random distribution of those three shapes. And each shape is, if we look at it, it looks like each shape is sort of equally likely to show up. And we can change this with the probability curve. So if I wanted to have more cubes, for instance, I can drag this down. Or if I drag this up, I get more donuts. And if I make it flat in the middle, I get more of that, whatever's in the middle here in the array. And that's the curve. And then we have the seed. I think that's pretty self-explanatory. Just give you a different pattern, random pattern. And finally, you have preview geometry, which I'm not using in this video because these geometries here are very low res to begin with. But if they were really high res, I could provide some low res proxy geometry, plug that in here, and then my viewport would be a lot more manageable. This is quite fast, so no problem with this at all. And we can also change the bounding box, then we get even faster viewport display. So that's it for the parameters tab. However, we have mask weights here, and what that allows us to do is specify for every point of that input geometry whether or not we want an instance there. So if we don't provide anything, each and every point gets an instance. But let's just do something very simple. Get the point count, create an array, and let's just print that. So we can see every point has a value of 0 associated with it. And if I use that as my weight, then we should see them all disappear. So a value of 0 or less is no instance whatsoever. If it's 1 or higher, we get definitely an instance there. And if it's in between, so let's say I put this to 0.5, we have a chance of 50% that a given point will end up with an instance. Of course, we can be a bit more interesting with the array that we're creating. We could use fractal noise field because this is an auto port, interpret auto port, so it'll accept fields. But I think I'm just going to move on to the next one, or the last piece of this compound here, and that's instance ID override. And I think that's the most important part of this node. So in order to understand this, I want to look at a property that this create instances node creates for us, and that's point instance ID. You can see here is an array of long, and it's targeting the point component, so it's a per point property. And in order to view the data, I'm going to use a compound that I created myself. But inside here, it's just a getGeoProperty node with that property name. So nothing fancy at all. And I want to print this. And here we can see what it is. So basically, it's just the index of that particular shape in this array. So essentially what we're getting is for each point we can get, or we can know exactly what instance shape is associated with that point. So anywhere there's a cube, it's a 0, and anywhere there's a donut, it's a 2, and so on. So this is pretty helpful. And this is being created by this node here. So if I change these values, we can see that these IDs change as well. But we can provide this array ourselves, and that's what this is for. So I'm going to repurpose my array here. Just going to set it to long. Print this. So now all zeros. So if I plug this into the override, what I should expect to see is all cubes. Let's see. Yes. And if it's 1, it's all cylinders, 2, all toruses. And interestingly, if we go above the maximum index, which is 2 in our case, then it's just going to wrap around. So 3 means going back to the cube, and that just keeps going. And lastly, I want to mention that if we set this to a negative value, we get no instance whatsoever. So that's another way to tell the compound you might not want an instance for a given point. You can use the weights here, or you can set this to minus something. So it could be minus whatever. And that's really it for this compound. And of course, again, you might want to create an array that's a lot more interesting than this, because if all you're doing is this, you don't need to do this, and you can just plug in one single shape here. But hopefully that explains it. And also, now that we've provided this, the point instance ID property values are going to be identical to whatever we're plugging into here. So if I print that instead, there's no difference. So let's unplug this and look at something else. There is a node called randomized selection by probabilities, and that is something that's a bit similar to the probability curve. It just gives you a different way of controlling it. So I'm going to set the first 3 elements here to 1, and everything else to 0, because again we have 3 instances here, instance shapes. I might also want to copy the seed. So with that setting, if I insert this here, I should not see anything change whatsoever. And we can see it's still the same. I'm going to print now the ID from here. So what I can do now is I can say I want more of the cubes and just crank up that number. So if I set this to 5, I should get roughly 5 times as many cubes as I get these other two shapes. And of course I can do the same for these values and just play with this until I get a distribution that I like. And if I have more than 8 of these, because we only have 8 of those slots, what we can do is use this array called more probabilities. And of course I can change the seed to whatever I want to get a different distribution. Maybe let's crank this up again, change the seed, and we can see the result. And this setting, whatever I'm doing here now, is irrelevant. It won't have any effect. However, we have a weights port here. So with this weights port, I can now blend back to this business here. So let's say I set it to sequential. I don't see anything change. But if I create a fractal noise field and I plug that into the weights, that's also an interpret auto port. We can see I have a sequential distribution with a little bit of randomness from this node here. And I can make this more obvious by increasing the magnitude. Something like this. So now we have a lot of control over what we want to do. And finally, there's some property here. So we're targeting that point instance ID. As we can see, if I change the probability here, we can see those numbers change as well. But there are use cases where you might want to change this, which is what we're going to look at in a second. So let's see. Let's unplug this. And let's look at these two guys here. So let's say I want to add another shape into the mix here. And I want this to be a helix. But I happen to have variations. I have a thick one and a thinner one. And so far we've seen that each instance is associated with a unique point instance ID. But what I can do is I can actually group instances under one and the same point instance ID, and that's what I want to look at now. And for that I can use the selector instance node. So maybe just call this thick and thin. And just bring those in. I want to zero them out and hide them. If I plug those into the selector instance node and connect that into my instance geometries array, I don't get anything because I need to set this one. Now we have one more shape, so we need to set this to 1. There we go. But currently, we see we have a new ID here, ID 3, and we do get a helix, however, it's always the same. So one way to control this now is to add one more of those nodes. So if I add this, so I'm dealing with 2 shapes on my selector instance, and now what I want to do is I want to define a property to control which helix is showing up, if that makes sense. And I can do that here. So I can give this a name. Let's say I call this helixes. I don't know if that's the correct plural. We can see them disappear, but we can fix that in a sec. I'm going to copy the name here. I'm going to use this here now as my property. And I'll plug that after the other one. And now sometimes there's a bit of an issue with the seed. You might have to change the seed, but now we can see both of them are here. And I can say now I want more of the thick one by cranking up that value or maybe I want more helixes to begin with, a lot more here, and then maybe one more thin ones, and play with those values, change the seed. So now we have a lot of control over our instancing. Another way to control this, what helix goes where, is to do the same thing that we did here with the instance ID override. And we can do this by, if I take this out of the mix again, well, actually, let's look at something here. We have now a helix geoproperty targeting the point component that's being created by this compound, because we can see here it's not there yet, and after this node it is. But we can actually create this property ourselves without having to use this node if we want to be 100% specific. So let's get rid of this. Helix property has disappeared. It is there, but it's quite a bit more. It's not a geo property, it's just a property, and you could print an object dump to find it somewhere, but we're not going to do that now. But basically, we just need to create a geo property, and we want it to be long helixes. So we can add this before or after, it doesn't matter. I think I'm just going to do it after. And now we're basically saying, because we're not plugging in an array, we're just using one value applied to all the points. Now we're just saying it's the thick one. If I said it's 1, it's the thin one. But I could, of course, provide an array for each point, and then whenever there's the point instance ID 3, it's going to look up that value of that helixes property and choose either one or the other. And also here we can wrap around, so we can just overshoot those indices and it will still pick one or the other. Of course, we can plug as many shapes in here as we want, and this is because wrap outer range is checked. We could uncheck this, and then this would not work that way. Okay, so what I want to look at now is how I can scale these instances, and we know that we can come here and we can scale those geometries, but that's not very flexible because it'll scale all of them. So what we have to do is basically create a point scale property. And we could do this before or after the create instances node. So the most direct and flexible way is to simply just write that property and then create the data ourselves. So we have to make sure we spell this correctly, point scale, like that. And there's going to be a float 3. There's actually another property that the instances would understand, and that's point size, but that's just a float, and I'm just going to focus on this one here, because this will give us the ability to use all 3 axes if we wanted to. So let me just simply create a sequence array that's the size of the number of points I've got, set them to vector 3, and maybe I just want each instance to increase in size slightly, and I'm just going to start at 0.1 and then 0.01, 0.01, 0.01, something like that. If I use that for my data and set this here, we can see that the instances are now just increasing in size. And then again, you can come up with your own way of how you want to create this array. So, and of course, I can change this in all axes. But there's another compound that's a little more high level that is quite useful, and that's called randomized point scale. This is also simply writing the point scale property. If you look inside, You can see here, this is simply another set geoproperty node writing the point scale. But it'll give you some options. So if I just take this out for a moment, and I'll plug in this, we can see that we're getting a randomized point scale. And we can change the seed, and we can change the min-max values. Now it is applying it uniformly, so it is writing a vector 3, however, it is applying it uniformly. And so you only have these float values as min and max. But you could change this, for instance, to y only, and then you'll get something like this. I'm going to go back here. One thing that's really quite handy to have is this checkbox here. So if I uncheck it and then reinsert my previous point scale operation, you can see nothing changes. So this one is totally lost. But because we have the option to use scale existing values, it'll take that into consideration, and then we get a combination of the two, which is nice. Okay, I think for point scale, that's fine. The other thing we need to control is the rotation. And the property that we need to create is called point orientation. As we can see here on the watch point, there is no such orientation. And because of that, if I come here, grab that plane and rotate it, there is no rotation inherited or anything. It's just simply aligned with the world. And again, we can just come up with a way to create our orientations ourselves, but the trouble with that is that you're going to have to think or deal with quaternions, which can be a bit scary. And the good thing is that there are nodes to help you convert things to quaternions, like Euler to quaternions. This is in radians. If you don't like radians, you can use degrees to radians before that. And then you can make sure that that's a float 3. So now you can just specify your Euler angles like you would in the channel box. So that's nice. Again, the property name is called point orientation, and then you can create your orientations like that. But what I want to look at is a little more of a high-level workflow. So there is a node called orient points by geometry. So I want to use this so my instance here will stick to the surface of the plane, not only in their position, but also follow the sort of orientation. And so I can use this for that. And, well, in this case, my points and my geometry are the same, so I can use this for both. And then it's asking for a locations port, so I'm going to use get closest locations. And I'm going to use these point positions here. And I'll plug that in here. And now if I use that as my incoming points, nothing changes, but if I rotate the plane, we can see that this is now working. And I can come here and let's see, I can move this up, and this is still following the plane. Basically, it's aligning itself with the normal. And this will give us a point orientation property. That's what this is going to write. And this is something to note here, that depending on how you are creating your points for the instances, you may already have something like that on the points, so you don't have to use this. For instance, if you have scatter points, this compound down here has a set orientations from geometry option, and internally it's basically using this guy here, orient points by geometry. So it's always good to check whether or not you need this. So if you have scatter points, you don't have to add this. And you can see down here, if you come to orientation, that you're going to get this exact same ports here. And I just want to quickly look at one thing where I am going to override the normal. Right now it's taking the normal from the mesh, from the plane, but we can actually say we don't want this, we want to override this. So let's say I want to blend between the point normal and some other vector, and I'm going to keep it simple. I'm just going to use y up. So I'll plug this in here as the first, and as the second, let's set the fraction to float first. As the second, I'm just going to use y up, and if I use that as my normal override, I can now blend between these two vectors, and therefore we can see how that affects the instances. And you can do the same thing with the tangent if you want to have a lot of control over how they're oriented with this high-level compound. Let's undo this. I'm just going to go back to the flat plane. And we also have, just like with the randomized point scale, we also have randomized point orientation. Or randomized point rotation, it is called. Again, we have the rotate existing values checkbox, very useful. And here now, if I plug that into here, and maybe I'll use all the other axes too, we can see this just gives me some randomized point rotation, or randomized instances rotation. And again, we could add a degrees to radians node if we're not happy with radians, but I'm gonna just stick with this for now. So now if I rotate that plane, we can see they're oriented along the plane, but on top of that, we're randomizing the rotation. If I uncheck this, we'll get the random rotation, but there's not following the plane anymore. And finally, these randomized nodes here have some weights ports. So maybe what I want to do is, maybe I don't even want to randomize the rotation. Maybe I'll just add one turn in the X. So let's say I'm setting this both to, well, actually that's 180 degrees, but never mind. I'll set everything else to 0. And for the scale, I'm just going to set everything to 8. Let's insert this here. Make it Y only. I've got something like this. And now I can use these weights ports to say where this actually happens. And for that, I'm going to just now use Roland's fall of objects, or manipulator fields. Where did it go? Somewhere here. And this is not part of Bifrost, but you can download this for free. And I'm just going to scale this up. You can get sort of like this fall of object. And if I use this field port here as my weight on both of those, we can see we get some interesting effect. So we can get some interesting motion graphics kind of situation with this workflow with the field, the fall of object, and the weights ports. So yes, I think that is pretty much all I've got for this video. And yeah, thanks for watching.